Let's take a look at the second page of this review, all about congruent triangles. It's not just about congruent triangles, actually, it's the attributes of triangles. Here's a good look at that. In triangle QRS, the exterior angle at Q, this angle, has measured 30x plus 14. I'll make that note. The measure of angle R, that's 20x minus 8. And I know the measure of angle S in terms of x, 15x plus 2. A big chunk of what we got to do in this class is write equations and solve them. You got to figure out the equation that fits here. What I hope you're realizing is the exterior angle of a triangle equals the sum of the remote interiors. We proved that this year, a couple weeks ago. So the application here would be that 30x plus 14 must be the same as the sum of these remote interiors. Remote just being the distant angles. And that would be 20x minus 8 plus 15x plus 2. We've got to collect like terms on the right-hand side. The left-hand side, keep it the same. 30x plus 14 equals, and here I have 20 and 15, 35x. And a negative 8 and a positive 2 give me a negative 6. Let's gather like terms. I got 30x on this side and 35x on that side. I subtract 30x from both sides to be left with 5x here. Minus 6 equals 14. This is getting pretty simple. I'll add 6 to both sides, and I know that 5x is equal to 20. So now I'm convinced that x is equal to 4. Let's see if we can figure out about these angle measures then. How about the measure of angle R? Well, if x is really 4, that'd be 20 times 4 is 80, minus 8, that'd be 72 degrees, wouldn't it? And the measure of angle S, 15 times 4, that'd be 60, plus 2 be 62. So I think that this angle should equal those two angles added up, and those add up to 134. Let's check on that now. What about that exterior angle at Q? 30 times 4, that's 120, plus 14. Yeah, there's that 134 that we wanted. So I think that is successfully done. But I want to show you this question. We had a homework question like this one, and it's a really good one. I think I'm going to put a question like this on the quiz that you got to take this week. Let's pay attention here. Triangle ABC is isosceles with base AB. Now, if this is an isosceles triangle with base AB, then these would be the legs. I'm going to pay attention to that. It also tells me the measure of angle B, 8x plus 2. It tells me about the measure of angle BCD, which is an exterior angle on this triangle, 15x plus 13. You had a question like this on your homework. It's a pretty good one. What you had to realize is we still got an exterior angle of a triangle, and it should equal the sum of these remote interiors. And because this is an isosceles triangle, those remote interiors are the base angles. They've got to be congruent. This would have also been 8x plus 2. It's all downhill now, huh? I'd say that 15x, let me let you see what I'm up to, 15x plus 13 should be the same as 2 of those 8x plus 2's. We'll solve that equation and see what comes. 15x plus 13 is equal to, and as I multiply through the parentheses with the distributive property, 16x plus 4. Subtract 15x from both sides as we gather like terms. That would just leave 13 on the left. When I subtracted 15x from both sides, I'm left with 1x plus 4. Subtract 4 from both sides, and I'm convinced that x is equal to 9. But I make mistakes. I better go back and check these things. Let's find the value of x. I think I did. And the measure of each angle. Let's go for the measure of angle A first, please. Angle A and B ought to be the same, but if x is truly 9, that would be 8 times 9 is 72, plus 2 more would be 74 degrees. So I conclude that the measure of angle B would have also been 74 degrees. That makes me think that this exterior angle better be 2 times 74, better be 148. Let's check on that measure of angle BCD. If x is truly 9, 15 times 9 is 135. 135, I got to add plus 13 to that. Yeah, man, I got 148 out of that, don't I? So I'm happy with that. I think that worked as it should. I think this worked out well. Meanwhile, back at the ranch, let's go back to this page that's prepared for you. And here we're going to find some angle measures. We won't have to write an equation. We'll use the isosceles triangle theorem and the triangle sum theorem. Here's a chance to use both of those at once. This is an isosceles triangle. I can tell by the way it's marked. And if these are the congruent legs, then we would have the base angles being at 1 and that angle at B. Those would be congruent. And I know that they're going to add up to 130. If you didn't, you would have figured out, well, that angle's got to be 50. Because you can subtract 130 from 180, that would leave the interior angle there to be 50. Then you can subtract 50 from 180, you're back to having these two angles add up to 130. But since they're going to share that 130 equally, they must be half of 130, 65 each. So I'll report that angle right there as 65 degrees. But then I think, well, these are vertical angles. I'm still looking for the measure of angle 2 now. And these are vertical angles, and that angle is going to be also 65. This is marked to be a right angle. There's no doubt about that. So that's got to be 90. And 90 and 65 add up to 155. If I take that 155 out of 180, I'm left with a measure angle 2 being 25 degrees. That's a nice question. That's just 25 degrees right there. I like this question type. You want to be used to this one. Let's mark the things that we know to be congruent. I have a couple of isosceles triangles here. I only know one angle, but I'm going to figure out every other angle. PS is congruent to QS. Oh, S was a midpoint, wasn't it? And QS is congruent to SR. So yeah, this is an isosceles triangle, and we ought to be thinking, well, where would the congruent angles be? And if these are the congruent sides, and here's the base angles. I know if 110 went here, subtract that from 180, and these have 70 to share. So I'm convinced now that this angle would have been half of 70. There's 35 degrees for the measure of angle 1. Angle P would have also been 35 degrees. I don't care about that right now, but I might check on that later. And if this angle is 110, I look at this triangle on the right. It's also isosceles. Who are the base angles? And if these are the congruent legs, then these would be the base angles. They're going to add up to 110, aren't they? They must be 55 and 55. I'm pretty sure that's got to be true. This one would have been 55. I'll put those numbers here too. 55 for that angle and 55 for that one. You've got to be figuring out which ones are the base angles. Then you can figure out which angles would have to be congruent. We looked at the little triangle on the left and a little triangle on the right. Never did look at the big triangle. I just want to be sure those angles add up to 180. I'm going to put a quick check on that, see that they do. The angle at P was 35. The angle at R is 55 and 35. That would have been 90. We found the angle at Q to be 55. Now look at those. Those add up to 180 because I know the angles of this triangle, that triangle, and the whole triangle should add up to 180, and I'm convinced that that adds up to 180. So I'm on my way, and I'm happy with what happened there. Oh boy, look at this. Got some parallel lines. Tells me they're parallel, but I can see it's marked that way also with these arrowheads. And I'm going to be looking for angles that would have to be congruent because those lines are parallel. And I'm going to use the triangle sum theorem as well. So, what do you think about angle 1? Well, if these lines are parallel, angle 1's an alternate interior angle with that 15-degree angle. It'd have to be 15, wouldn't it? And the measure of angle 2, well, that's going to be the alternate interior with that 30-degree angle. So the measure of angle 2's got to be 30. Not 3 degrees, but 30 degrees. Let me just go ahead and put that 30 right there. So how can I find out about angle 3? I'll say, well, you do know two angles in this triangle, don't you? That's 15 and this 30 add up to 45. Subtract that from 180, you get 135 degrees right there for the measure of angle 3, the angle at B. Here's a real good question. Pay attention here. PX bisects angle APC. We got to mark this to be an angle bisector. Those are going to be congruent, aren't they? And we have three triangles to work with here, a little one here, a little one there, and a big one. When you have the angle bisector circumstance, you ought to look at that big triangle first. I know two of the angles add up to 100. I got a 70 and a 30. And how much would that angle leave? How much would that leave up here? That full angle would have had to have been 80, wouldn't it? Because there's 100, we expect 180. So that full angle would have been 80. So what about angle 1? Either one of those would have been the same. That would have been 40 degrees. So I'm thinking that angle's 40 right there. This one is also 40. But I've got to figure out about 2, 3, and angles 2 and 3. If this one was 40 and that one's 30, those add up to 70. That makes me think angle 2 would be 70. But you could add up 70 and 70. There's 140 and 40 more. Yep, there's 180 there. So angle 2 would be, let me get this right, this was 40, this is 30, there's 70. So angle 2's got to be 70, doesn't it? And angle 3, well, that's got to be the supplement of 70, which is 110. But it should also equal these two angles added up. I love that an exterior angle of a triangle equals the sum of the remote interiors. So that's going to be 110. 110 degrees. A couple more to play with here. Now, I don't see anything being isosceles here. I'm not going to use that theorem, but I can use the triangle sum theorem. I see that this angle is marked to be 50, and that's a right angle. So it's 90 width there. These two will have 90 to share. They're going to be complementary angles. That angle had to be 40. Did that tell you about angle 1? Yes, it does. Angle 1's a vertical angle with that 40-degree angle. We know that vertical angles are congruent. So I know that this angle had to have been 40. I also see that this full angle is, if I read that carefully, 140. Well, I can figure out that this is 40 right there. And 40 and 40 is 80, so that'd leave 100 right there. Or I could realize that this exterior angle equals these two added up. Yeah, I'm thinking that angle 2 would have to be 100. 140 went there. That would leave 40 for this angle, wouldn't it? And 40 and 40, there's 80, leaving 100 for this position. So I got those few angles. One more time on this page. Beautiful question. This is an equilateral triangle, isn't it? We should know about the measures of the angles there. If it's equilateral, it is equiangular. These three angles must be congruent. And they got to add up to 180. So they're going to be 60 each. So what do you think about angle 1? It's got to be 60, doesn't it? And this is a right angle.